This is the second part of the video lecture for Math 110 for Monday, April 27th. And the topic today is the applications of the laws of sines and cosines. In part 1, we did an application of the law of sines. In part 2, we're going to do an application of the law of cosines. So here's the problem we're considering. A car drives 70 miles due east and then drives 50 miles at a heading of 30 degrees north of east. Now we're going to ask ourselves some questions about this situation. But as a first step, we should draw a diagram of what's happening here. So this car is driving due east at 70 miles. And so this car we can draw a line like this. This is due east for 70 miles. This is 70. Okay. And then the car turns and drives at a heading of 30 degrees north of east for 50 miles. So the car turns like this and drives like this for 50 miles. Okay. This is now 50. And what this means at a heading of 30 degrees north of east, it means that the car turns from going due east to traveling at 30 degrees north of east. So if I draw a dashed line to continue this original heading of due east, let me redraw this distance here. This means that this angle is 30 degrees. The car is turned by 30 degrees. And then what I want to do is I want to connect these 2 points here to complete my triangle. Let's see if I can do that successfully. Like that. It's not a perfect triangle, but you guys get the idea. So now I have a triangle here, and I can ask myself some questions about this trip. And one of the first question is, how far does the car end up from its starting point? Okay, how far does the car end up from a starting point? It starts here, drives up here, ends up here. How far away is it from its starting point? Hopefully you guys see, I'm going to call this distance D. Hopefully you guys see that this is just D. This is this leg of this triangle. This is how far it ends up from its starting point. Okay, how do we find D? Well, this is a classic law of cosines problem. This is an SAS triangle. Okay, we know a side, an angle, and a side sandwiched between those 2 sides. And so I can use the law of cosines. So now I'm looking for this side, okay? And now by this equation, what this says is this side here, in this case this side is labeled D squared, okay, is equal to the other 2 sides. So D squared equals 70 squared plus 50 squared, okay, minus 2 times 50 times 70 times the cosine, and now we've got to be really careful. This angle is 30 degrees, okay? What is this angle right here? Well, hopefully you guys see that this angle is the supplement of this angle. If this is 30 degrees, and this is 180 total here, this angle has to be 180 minus 30. So this angle is 150, okay? Be careful here, because the temptation is to plug in 30 degrees cosine of 30. But this is not the angle that's opposite side D. This is the angle that's opposite side D. So I plug in cosine of 150. And now I go through calculating D. If I go through the steps here, the arithmetic. Where's my sheet? There it is. If I go through the steps here, I get, if I square 70, it's 4,900 plus 2,500. This term right here turns into a plus 6,062. Be careful here. We have a minus sign here. What happened to the minus sign? Well, the cosine of 150 is negative. Okay, so 2 negatives make a positive, which makes this term positive. Be careful about this. This comes out to 13,462. So now D is the square root of that. And if you guys take the square root of that, you get 116 miles. Okay, so D equals 116. So in this problem, this driver ends up 116 miles from his starting point. This is a good application of the law of cosines. The second part of this problem has to do with the heading. What heading does the driver end up at? So what is the driver's final heading? In other words, if you look at the starting point of the driver and where he ends up, what heading is that? And any of you guys who might do aviation, you know that it doesn't. If I tell you guys that I ended up 100 miles away from you guys, that doesn't pinpoint where I am. You also have to specify an angle. I ended up 100 miles, 52 degrees north of east. Okay, so that's called the heading. And the heading is actually this angle. I'm going to label this angle theta, the Greek letter theta. This is the heading of the driver. So how many degrees north of east did this driver end up from his starting point? We want to find angle theta. How do we do that? Well, now we can actually use the law of sines to do this angle. And we know that this angle theta, we can write sine of theta divided by the side opposite that angle, which is 50. This is using the law of sines. Now we can use this side angle pair is equal to the sine of 150 degrees divided by d, which is 116. We solve this for sine of theta. Okay, and I'll let you guys check the arithmetic on this. If you guys solve this for sine of theta, this comes out to 0.216. Okay, that's sine of theta. And then finally, to get theta, we take the inverse sine. The inverse sine of 0.216. Okay, what does that come out to? It comes out to 12.4 degrees. And then the way we would write this is north of east. Okay, so this is the final heading of this driver. This driver ends up 12.4 degrees north of east from his original position. And he ends up 116 miles away from his original position. That uniquely determines the position of the final position of this driver from his initial position. Okay, in part 3, we're going to do one more example problem, application of the law of cosines and sines.